All right. So I haven't done anything yet with this data. So the point is, I want you to see what I would do, like from start to finish with this data set. Okay.
Is this going from installation or just from?
It's not going from installation because I've got all the stuff set up on my computer already, but I will explain what I did to get it there. I have to do a screen share. Okay. Right. Then to do this, it's use IPython notebook. I'm just gonna mute you.
It's not called IPython.
Oh, it's called something else now, but the command is still IPython notebook. Oh, it's still IPython notebook, but it's called something else if you're on Windows, I think. I might be wrong about that. It's called like Canopy.
Jupyter.
Yeah, like that's the, yeah. All right. So the way that it works is that it looks, it can access any file system in below where it is. So it will go, you can see that, right? Can you see my terminal? You there? You there?
Oh, yeah, I am, sorry.
Okay, cool.
But your screen's like little pixels.
Oh, okay.
Like the text.
Okay, so I'll do it a bit smaller, I guess. Stay on, don't mute, because then I can't tell if you're still there or not. Right, screen share. And just a second. Make my terminal a bit smaller. There we go. Right, can you see that?
Yeah.
Good. Right. So I'm in the folder where everything sort of happens. So we'll go IPython notebook, and that will it'll actually do quite a lot of magic all in one go. It will load the notebook. It will start the notebook server, but it'll also open the window and everything. So I don't need to worry too much about what's going on here. Okay, right. So that's opened it. That's cool. So I'll just leave that tab running, and I will go to here.
Is your project directory, is that just in like your documents or something?
Yeah, I just have everything that's mine in one folder, so I know what to back up and what not to bother with. Right, so I can get all the latest stuff, and it's all in there, right? You haven't put it in it. You didn't put it in a different repo. Okay, cool. All right, so look in here now. We can see there's a bunch of stuff, and it's in helpers. So cd helpers, experiments. X. 6 or 7? Which one are we looking at?
Yeah.
No.
7.
7.
EXP7.
So in there, we've got a picture and some JSON, right? Which is just a file extension. Right. All right. So
I think you have to go in raw JSON as well.
Oh, okay. So that's why it's right. Okay, that makes more sense.
Oh, hold on. Sorry.
Hey Ben,
You can't, Ben. Alex can't see your screen.
Is that because he didn't join the thing?
Is it because you didn't join the thing?
Maybe.
Did you accept the invite?
So you have to accept.
Yeah, you have to accept it.
It's public.
I'm doing it through
You should be able to
Hangouts.
join it. And it's being recorded as well, so you can catch this early bit. All right,
Okay,
so
go on.
we've got something that looks kind of like JSON, but I don't think it actually is. So the first thing I'm going to do is open it up and do some processing on it. So I'll go to sharing my whole screen, and so stop that, share my screen, entire screen, share. Okay, so here I'll go Sobel because I want to edit everything. So can you see that, or shall I zoom in on just the bit I'm working on?
Yeah, please.
Okay, so stop that. Start. There we go. Right. How does that look? Can you see that?
Yep, ish.
Open
Should be okay.
4meter.json and have a look at it. All right, so there's some kind of weird stuff going on in here, which means that it's not legit JSON. So some of this is to do with my editor. Some of it is to do with some other stuff. Okay, so the first thing I'm going to do is do a find and replace on single quotes and replace them with double quotes, because that's a JSON spec thing. So just replace that like with a replace all, and it suddenly starts to look a lot better, right? The first, so that line 2, BLE thread started, is not JSON.
Yeah.
Okay, so we can get rid of that line. And the
first line as well.
First line is kind of weird, so we'll get rid of that too. And then we'll open a list, because JSON needs to have that list. And then we'll jump straight to the end. And there will probably be some other weird stuff in there. Yeah, like, what's that? Error, failed to upload to server 2 times. So, and we'll close that list. Now, we're going to see that the ends of those lines don't have commas on them, right?
Yeah.
So,
yeah.
So there's an easy way to fix that. Do an Alt F3 multiple select, and then put a comma behind that. Okay.
Wait, say it again.
Alt F3 does multiple select. So let's say I want to select all the majors. Let's do something that's more obvious. So I want to select all of those 9752. So highlight the thing, Alt F3, and that select all the 9752. So I could change them all in one go if I wanted.
That's better than what I did.
Yeah. This is why learning your editor is important, because you can save like days of work. All right, so we'll do a quick auto prettify just to check that it's legit. There we go. So it seems to have indented properly. Okay. So that looks to me. Oh, there we go. There's a bit of bad JSON. Error failed to upload to server 1 time. So we'll get rid of that. Now, I use a website to check this stuff. So I'll just do that. Coded JSON editor. What it's called. JSONeditoronline.org. And I just paste it in and it checks it for me. So there's something wrong on line 1516. So the good thing is it gives you a line number to check. So if we just go straight to 1516, 1516, the very last line. Oh, it's got a trailing comma, that's all. So PS 2015, I think, allows trailing commas, but JSON obviously doesn't. Okay, so that's legit. That's good JSON now. So we can save that. Okay. Then I need to change what I'm presenting. And we'll go to IPython and we want to go into, I want to show you what I'm doing first. So present, home, share. Okay, can you see that? Is that good enough quality, or do I need to make it smaller?
Make it bigger.
Well, that's what I mean by bigger. I mean, I need to make
Oh, right.
How's that?
Mm-hmm.
You can see that? All right, so we'll go into the folder that we care about. Not code 2016. I want to go into my blog. No, sorry, where am I going? Tucson. This is me. This is where you get to watch my brain not working very well. Helpers, experiments, EX6 or EXP7? 7, right? Raw JSON. All right, so we make a new notebook. And then the other thing we'll do is go to EX6, and then we can run the other notebook, so we can basically rip off large portions of it, right? So these are the things that we've used so far, so we'll put those in. They import libraries that are useful. These lines essentially tell you to return the graphs afterwards, rather than just returning a little bit of text that says this is an object. And then we want to read in some JSON. So in our case here, this file is called 4-meter JSON, the one we've been filling with. So we need to make sure that we get the file name correct. Now, because we're in the same folder, we don't need to put any file stuff on it, right? So we'll call this data4 just to make it nice and simple. Okay, so we have a data4 object already now. So we can say head. Oh, I can't remember which way around this goes. Yeah, so we can say data4.head, and that will give us the top 5 rows by default, right? So we can see that it's loaded it incorrectly, yeah?
Mm-hmm.
All right, so we can also do something nice and simple, like saying data4 dot RSSI. And that gives us a list of the RSSIs, right?
Mm-hmm.
And then if we say .hist, it gives us a histogram of the RSSIs. So that shows us the distribution. So most of them are about -80, but they go as low as -100 and almost as high as -50, right?
Yeah.
Okay, so we know that the data works. We're kind of happy with it. We could change that to TX and run that. We can see that the TXs, there's only 2 TXs, right?
Mm-hmm.
Which is kind of what we expect, because there's 2 of them, two things. Okay, so run that again, we'll see that. So what we probably want to do, this is still the rotatey thing, right? So we can basically rip off large portions of this to do this same stuff, right?
Mm-hmm.
So in fact, actually what we can do is just change, we'll just copy it across, it's fine. So first thing we're going to want to do is run this command, which converts the timestamp from a string into a timestamp. That makes sense? So at the moment, it's just a string that looks like a timestamp rather than an actual timestamp. So run that, and it says data 1 not understood, data 4, and it worked fine. And we can test that by running this guy. Change that from 1 to 4. Right, so we know that we've got an actual timestamp and an actual thing that's definitely the right thing. So we can come down here, and if we wanted, we could run the head thing again. But let's just plot that graph. Should be. I'm going to remember to change all the 1s to 4s this time. So what this is doing is it's just plotting the x and y of timestamp and RSSI. So we should see a pretty thing there. All right, so we're going to kind of bump there, and there. Does that sound right? 4, 1, 2, 3, 4, 5, 6 humps. Who knows? Let's split them out by user, not user by. Did you do both beacons? You did, didn't you?
Yeah.
All right. So what this will do is it will complain because I've changed from 1 to 4. 4. 4. There we go. So that just splits the data frame into 2 data frames, one for one beacon, one for the other beacon. I think I basically ripped that off from a Stack Overflow thing, so don't get too intimidated by it. Then we'll add another one, and this one. So this one does. There we go. So data frame dictionary 5. It's looking for data frame dict is split into 2, right? And there's 2 things in there. One's 5, one's 9,752, and those are the 2 groups, right? Estimote and the hockey stick, hockey puck. And then we plot them, and this is just a label and a label. So we're plotting them both on here, and then we put some X label, Y label, and a title, show the legend, show the thing. So we can see that the hockey stick had stronger signal almost every time. There's a few kind of weird things in it. Excuse me. So I'm making yogurt. All right, so we've got that, and there isn't an obvious sine wave in there, right? There are some sort of fairly periodic looking humps. So 1, 2, 5, 6 humps. Is this channel here at the beginning? Is that what you were saying was the bit that it takes a while for it to pick up?
Yeah.
Okay, so let's try processing some of these other JSON files and see how we go. So I'll just switch to here again. And feel free to ask questions and things. So we want to switch to there. Okay, so if we go to, let's say 1 meter, do you want to talk me through what I'm doing here?
No, not really.
You're going to have to do it yourself one day.
Yeah, I'll look back on the video.
Okay. I'm doing a find and replace for single quotes, replace them with double quotes. Okay, so that's everything. We'll go to the last line. put in the closing bracket, and then Alt F3 to select all, put in the comma at the end, and take out the last comma. Just run that across to the testing website and check it. All right. That's not right. I seem to think there's only 150 rows. Maybe there are. Yeah, there's only 150 things for the 1 meter.
Yeah, they all have different. Wait, what was the one you opened just before?
No idea. Let me have a look. 4 meter. Well, 4 meter ran to 1500. So let's try it and see how we go.
Wait, what was the timestamp for that one?
Well, the first timestamp was 1630. Or no, the last timestamp was 1630, and the last timestamp in 4 meter was 3 in the morning. Oh no, sorry. That's 3:16, and this one is 3:40. So it looks like 1 meter just wasn't running for as long. So let's load it up and have a look. So this is JSON editor online. You got that? So
Yeah.
all we have to do to change the thing, I shouldn't really have called them numbers. So we've got to add data here, and we'll change that to 1. And then what we can do here is we can say run all. That will just rerun the whole program. So that gives us our graph, basically. It doesn't look like there's really enough data in there to make any kind of decent predictions there. So I think we're going to have to go and have a look at the other files. So let me stop there. Go back to here. Let's say 3 meter. Now, 3 meters got 1200, so that's more like it. So Control H to get to find and replace. Find and replace the singles with doubles. Commas on the end there. Go right to the end. And take that last comma off. A bit of a think. Have you got IPython? Have you got a notebook thing running yet?
No.
Okay. We'll get rid of that. Prettify. Okay, that all looks fine. The nice thing about the highlighting is that if it's not right, it will highlight wrong. Okay. Save that. Stop it. Go to here.
Oh, I know why the 1 meter.
Go on. What's the name?
Because there's an updated one.
What do you mean it's an updated one?
There is an updated one.
Oh, there's another one for 1 meter.
Yeah, but I
Okay.
don't have my laptop with me.
Okay.
Oh
Well,
no, wait.
you know how to
No,
do
wait.
it, right?
It's in the Raspberry Pi. I'll just get it from there. Yeah, I'll just give it to you later. Like,
Yeah. Okay.
you help
Well,
out.
you can do it. You know how to do it now. Right. So we did the 1 meter. We did the 4 meters. We can do the 3 meters. So one or below. Ding 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 ding. All right. Okay. So we're seeing roughly the same shape, right, between 3 meter and 4 meter, which is good, right?
What program are you using? Is that Grasshopper?
Dynamo.
Okay, it's
similar to-
Grasshopper for Revit.
Yeah. Have you tried it?
No.
Don't. Unless try Grasshopper first.
Is that Gary?
It's all through my
Yeah.
Tell Gary to piss off. All right. So yeah, we see a roughly similar graph. See the shape is roughly the same. So how many times did you rotate? You say 4 times.
So no, 5 times.
Oh, well, that's much more like it. 1, 2, 3, 4, 5 peaks. Okay. Which is good, right?
Well, technically we turned around 4 times, but that doesn't include the first one, if that makes sense. Like the first
Well,
one.
you get back to 0. You get back to 0 on the last turn, right?
Yeah.
Okay, so that's
But
good.
there should be 5 times. Yeah.
So what is to load this up with multiple data sets and then overlay them, which is actually all demonstrated in this file. You just have to kind of do it. So let's have a look at how we would do that, and then you can finish it off. My computer's having a bit of a tantrum, fairly major tantrum. All right, so come on. Here we go. So to load up multiple data sets, you see how we've got this line here? It's got data 4, 3 meters. That's not really particularly good. So we'll say that's 4 meters. And that will make data 3 be 3 meters. All right. So we need to do the same thing here. Change that to 3 and 3. And then we can do what we can do here.
So when do you want to do
Change that to 3. I think what we'll have to do is say .show, plt.show. And then, oh, there we go. So does that make sense to you, Vanessa?
Wow. Is the top one 1 meter?
Well, no, the 1 meter is not in there. We've only got the 3s and the 4s at the moment. But my guess is, we'd have to go and check it, that the 3 meters are the blues and the 4 meters are the greens. So we can do that by just adding a label here. So I think we can do this. Label. Okay. Right.
Is the green the estimate?
In this case, the green is the 3 meter. That's interesting.
The top's 4 meters?
The blue is 4 meters. Can you see there's a legend in the corner there?
Oh, it's very small.
Yeah, okay. So you'll be able to see that better. And so if we let's do the same thing and like process the remaining one, and we'll show all of them on the same thing. So this is basically how I think you guys should be processing all your data from now on. It really kind of freaks me out when you come up with single values for things, because there are no single values in your data set. So it worries me about where you've got that number from. You know what I mean?
Mm-hmm.
So okay. I think that's good. Verify code. Yep, that's fine. Save that, and then am I presenting? There we go.
So,
All right. So now if we go back into here, can we just make that one be 2? And now if we were feeling really fancy, it would make sense to combine all of these JSON files into one big data frame, and add in an extra thing in using basically the same method we use here to deal with the adding in the timestamp, right? I haven't loaded that file yet. So we'll just. Now the nice thing about this is that your data all overlap with each other. There we go. Ah, that's weird. That's very weird.
that's 2 meters. Red.
Yeah. So your two.
Oh, that is actually really weird.
Your 2 meters seem to
be higher. I mean, be lower.
Well, the 2 meter seems to be in between 3 and 4, which is weird.
That's what happened with the first one as well.
Is it possible that you mislabeled them?
No.
Okay.
Because yeah.
All right, that's fine.
But yeah, that happened with the first one as well. I was like really confused as well.
I wonder if it happened with the walking data as well. Anyway, the other thing that's kind of weird is that they seem to be out of phase with each other. Oh, that's correct though, isn't it? Because they should be like 90 degrees out of phase from each other, right? Because were they all laid out 90 degrees rotate from each other? Yeah, so that looks about right, and that one of them is in the trough of the other one. So if we hide the 2s, okay, so that's like, if you imagine if that's 360 degrees from there to there, then that looks like 270 degrees, and this, that looks like 90 degrees. Does that fit with what you're thinking?
Hold on.
Yeah, this one.
Okay, cool. Yes. Back.
So, alpha, okay. So let's pop some alphas on here so that we can see what's going on a bit better. I don't know if that's any clearer, but we'll see. So off the top of my head, I'm not sure how I'd rotate that. I'd have to have a little think about it. But we need to basically do a time shift. So we can work out the distance between those peaks. Give me a second.
Yeah.
Sorry, this is a little like cooking intermission. Stir some stuff in. Yeah, so, okay, so what we'd need to do with this is work out what the peak to peak time is. And you know that because you know what your rotations were like, right?
Yeah.
So what were the rotation times? What was a full rotation?
4 minutes.
4 minutes, okay. So what we would need to do is work out which one needs to be rotated by which amount, right? So north needs to be rotated by 0. East needs to be rotated by 1 minute, etc. Does that make sense?
Yeah.
So
they all, the humps like sit on top of each other.
yeah, that's what we'd want to see. So to do that, this is like a. Can you see that? Is that pretty clear? It needs to be sort of pretty obvious what's going on.
Mm.
Okay, so what we've got here is that's a Python function, right? Which you're pretty comfortable with the concept of a Python function.
Mm-hmm.
Right. So what we're doing in the 3 lines below is we're doing an apply. And what an apply does is it takes a function and applies it to the data frame. And so a data frame is a bit like a spreadsheet. And so you can kind of think about this more or less like a spreadsheet function that we're applying to the whole thing to make a new row. Does that make sense?
Mm-hmm.
Okay, so what we can do here is we'd want to write another function that would return the timestamp, but rotated by the amount that we want to rotate it by. And by rotate, we just mean add an amount of time. So then to do this, we should add in there. Because we need to work with timestamps, not with strings. So we'll do it afterwards. So then rotate. Let's not call it rotate. We'll call it add time. And we'll do it low. And we'll add another thing. So Let's do this in a couple of lines first. So print. So something that's probably good to do here is just to do a little test, like exploration. So let's pull out a row. So oh yeah. So all right, so we want to look at the pandas docs. Let's get a row. Okay, so get a row by so get that out. Ah, it's iloc, that's it. It's pretty weird. There we go. Right. So that's one row. Okay. So we know we can mess around with that a little bit. So we'll say row. IPython returns the last thing in the thing. So if we assign that, it won't do anything. So the reason I've got that test row in there is because we want to be able to see what we're looking at. Okay, so now what we want to do is to say test row, like that, and that gives me the value, and it also gives me the type. So if I say +1, I'm pretty sure that will freak out. Yep, it does. Okay, so the reason it's freaking out is it's saying incompatible type for a date time plus time / time delta operation. Python has this concept of time deltas. So we'll look at the Python docs for time delta. And a Python time delta is a difference between two times. So down to time delta object. Okay, so right, here we go. That's how we make it. So we don't want it to be a microseconds thing. We want it to be a minute thing. Try that. Time. We're not importing the whole of. We're importing the whole of date time. So there we go. Right. So we'll print that, and we'll print that, and we'll check that they're a minute apart. So you see we've got these two timestamps now. One of them is at 3:12, one of them is at 3:13. You with me?
3:12 and 3:13.
Here.
Yeah.
And
yep.
And so we've managed to switch one. We've just added a time delta of 1 minute. Does that make sense?
Yeah.
So what we're going to want to do is say that we want to return row dot timestamp plus date time dot time delta minutes equals time. So does that make sense?
Mm-hmm.
All right. So, what order were these in? Was 1 meter north, or was 1 meter?
Yes,
So data
it was
two.
going yeah, clockwise.
Okay, so data 2 is going to be this amount, and then we'll do the apply. Okay. And axis 1 on the end there tells it to do it by rows rather than by columns. That's all it's doing. So data 2 rot. A bit better name than that. Time, and we want to apply. We want to apply add time. And so 2 is 1 minute, right? We want to add 1 minute.
Yep.
Okay, 1 minute. And then we'll try and run that. And then let's have a look at the head of data 2.
Hold on.
Isn't it just copy and paste? Isn't it just copy and paste?
You back?
Yeah.
Okay, so 4 meters would be rotated by 3 minutes, and 3 meters would be rotated by 2 minutes. Is that the way it works?
I hope so.
Okay, well, if it's not, we can come back and fiddle with it. So if we run that graph, we get this, and it shows that 3 meters is 90 degrees out. So we need to add or subtract 2 minutes from there. Does that make sense? Does that feel right to you? So,
Well, that's very
so if we offset that by
hectic.
0. Yeah, that makes more sense. So it'd be worth checking that out with your, I presume you took lots and lots of photographs this time, right?
Just one.
Just one photograph. Okay. Because then you're not going to have a way of telling, like the data basically tells me that your 3 meter data is rotated by no amount against your, oh, hang on, one of these needs to be not rotated at all. Oh, that's your one meter,
Yeah.
right?
Yeah.
So 1 meter data is not rotated at all. 3 meter data not rotated at all either. seems weird because that's directly behind it.
Yeah.
And then left and right are rotated by the amounts that we would expect them to be rotated by, which is kind of weird. Anyway, so now you've got these three peaks, and that's interesting. Yeah?
Why is that 2 meters? That's really weird. Yeah.
Sorry, which?
The 2 meters stronger than the 3 meters.
I don't know. That's what I'm wondering about, is why these things are the way they are. If we had lots of photographs, we could have a look at them and find out. But anyway. Then I'm guessing that what happened is that you started the 3 meters first, and then you started the 2 meter, and then you started the 4 meter, and you started the 1 meter between the 2 meters and the 4 meters. Would that be a reasonable assumption?
No. Wait, say it again. You started.
You started the Raspberry Pi, you pressed go on the Raspberry Pi
Yeah.
in the order 3, 2, 4.
Oh.
3, 2, 1, 4.
Well, generally, we just Oh yeah, they all started at different times. I don't know which way I started. I didn't know. But
Well,
that's why I said that we're only going to use what from the start and end time.
Yeah. Well, what I'm saying is that if you knew what order you started them in, you could see whether they were out of order or not.
But they all had the same timestamp though, because we're going off my computer timestamp.
Yeah. So that's good. That means that's correct. But what I mean is, like, if you knew which order you put them on with, then you could check that you've got them the right way around. Because at the moment, it looks like you've got the data set labeled
3, 2. Yeah.
So I think it will be interesting to see what happens when you add the 1 meter in.
Mm-hmm.
Because if you started them 1, 2, 3, 4, then 2 is actually 3, which would be consistent with the power drop off. Does that make sense?
Mm-hmm.
So this is kind of why this sort of thing is useful, because you can look at your data and say, is this correct or not? And then it'll take me a little bit more effort than I've got right now to do the transform into a rotation, like a polar graph. But if you can get this updated so that it's got the 1 meter data set in there, I think we'll be pretty strong.
Okay. Hopefully.
And then we can do, at some point later, we can go back and say that we'll add in all the other things, like splitting it between Eskimo and Hockey Park and all that sort of stuff.
Yeah.
And then the other thing you can do, if you feel like it, is you can start messing around with the way that the graph is presented. So you can do things like tidying up the numbering, all that sort of stuff. But I think that this clear sine wave is a pretty good bit of data. It's interesting that you turn them off at different times as well.
Yeah, because some of them, they don't do a automatic reboot. I mean, yeah.
Okay.
Automatic run of the script.
Yeah, that's cool. All right, so I will save this as, what's the experiment name? Is it 6?
7.
Yeah, 7. Exploration. Okay, and then I will push it back up to GitHub. So we can go back to switch to GitHub. Hello. Here we go. All right. So all right, so we can add hoppers, experiment, EX7. So now we don't really want to add in the checkpoints file. Well, why not? Let's check it. Let's just chuck it in. Okay. So what we can do now is we can commit that. Exploring. Push it up. So now you should be able to pull that down and add in the 1 meter and add in the like lines for the 1 meter stuff, and you'll be able to see what the 1 meter data does.
Yeah.
Does that make any sense to you?
Yeah, it makes sense.
Okay, and you can use the same method to start to look at your data from the other thing. So once you've got the data loaded into an IPython file, let me know, and I can take a look at it, or we can look at it together in a way that will allow us to understand that saturation point, as you're calling it, the idea that like at some point it might settle down.
Can't do it now.
No, that's cool. I don't really want to do it now. But what I'm saying is that what we can do there is we can run, we can come up with some sort of measure for it, and we can run a loop over it that will change the measure until it finds the like sweet spot.
Yeah. Okay.
All right. So yeah, let me know when you've done it, and we'll reconvene.
Okay.
Yeah.
All right.
Bye.
Thanks, Ben. Bye.